Welcome to the CAD Office Training Guide series for FDOT Connect. I am Todd Holt, CAD Applications Training Coordinator. Today I will be going through the Roadway Design Existing Modeling Guide. In this series of videos, I will take you step by step through each exercise from the guide. Today we will start with Chapter 5 of the guide. This guide will go over the fundamentals of creating a 3D model for existing features to include hard surfaces such as asphalt, concrete, sidewalks, and curbs, existing utilities and existing drainage structures, and soil borings. Participants will be introduced to Bentley Open Roads Designer Connect Edition, Open Roads Technology Tools for Design and Modeling, specifically for an FDOT project, using the FDOT Connect workspace. Let's begin. Topics covered: create an existing drainage MODL-RD file. We'll reference the GDTM-RD and the SERV-RD. Using the Extract from Graphics tool, and view existing drainage and cross-sections. Chapter 5, Existing Drainage Modeling. Introduction. These exercises will introduce a new ORD workflow menu that will be used to lay out existing drainage pipes and structures. The Drainage and Utilities workflow in Open Roads Designer will be used when using the Drainage and Utilities workflow. A SUDA and SU database will be added into the file. A new MODLRD file will be created, and the optional modifier from the Create File tool will designate it as the file for existing drainage. Example, MODLRD underscore existing drainage 01.dgn. Elements will be extracted from the 2D elements and given features for 3D. This will be done in order to see the existing drainage in 3D model and then can be seen in the cross-section. Exercise 5.1, creating existing drainage model file. Open the blank file.dgn workset that was delivered or any DGN file within the 2204955 201 underscore CE workset. Starting with the create, I'll click on the FDOT tab. I'll go to the Actions group and Create File. I'll launch the Create File tool. I'll change discipline to roadway. The file group will be set to roadway design files. And I'll pick the base file name of MODLRD, 3D modeling file existing and proposed. I'll key in the modifier an underbar, capital EXISTING, and then drainage. The output folder will be roadway. The county is set to Wakulla. After setting the county, that'll set the coordinate system. Once these settings are verified, I click Create and Open File. That will launch us into the file. I'll verify that I'm in the new file that was just created, so the MODLRD underbar existing drainage 01.dgn. I'll then close the Create File tool. Once the file opens, change the workflow from Open Roads Modeling workflow to the Drainage and Utilities workflow. Then we'll switch to the Layout tab and select the Place Node tool. A message window will pop up. You cannot undo this action. Click the Yes button to proceed. Once we're in the MODLRD existing drainage, we'll switch the workflow from Open Roads Modeling to the Drainage and Utilities workflow. We'll switch to the Layout tab, and then in the Layout group, we'll click the Place Node. The message, you cannot undo this action. This action will create a utility model in the design file. You cannot undo this action. Proceed. We'll click Yes. What's happening? This message that displays the first time when you are setting up a drainage or utilities file is normal. This file will become a utility model and will attach a SUDA and SU database. This file will be different once this step is complete. So we'll click Yes. Exercise 5.2. Reference the GDTM-RD existing ground and the SERV-RD file for the existing drainage. We'll open the reference dialog. This can be done from the Home tab, the Primary group, and Attach Tools. Also, the F9 function key will open up the reference dialog. We'll then attach the references. We'll navigate from the roadway folder that it puts us in, up one to the root of the project, the 220495, and find the survey folder. We'll attach the GDTM RD file and also the survey and click open. For the GDTM RD file, we'll give that a logical name of GDTM and click OK. The survey file, we'll give that a logical name of DREX for the existing drainage and then click OK. Once those two are attached, we'll fit view. You'll notice that we have an existing ground and our survey attached. From the level display, we'll click on the second attachment, the ServRD file, with the logical name of DREX. We'll go to Levels, and then switch the levels to filters. We'll find the level filter standards.drexrd file. That will display for the survey file only the existing drainage. We'll switch back to levels and verify that we have just our utilities or the drainage levels shown. And then we'll click on the GDTM RD file. And if we can't tell what files is selected, we can click on highlight and that'll show what reference file is selected. We can close that. We'll go back to the element selection tool and select the DTMEX or our boundary for the existing ground and set that active. This will set up a 3D model in our file so we can start extracting from graphics. Once the existing ground is set active, we'll right click to bring up the view control and we'll pick two views, plan and 3D. That will set up a plan view in view 1 and a 3D in view 2. Make the view 2 active. We're going to turn off the existing or the ServRD in view 2. We'll go back to our level display, click on the survey file, and then turn all off. Or we can right click on the survey file and turn off the display. That'll turn off the display, only seeing the existing ground. Go ahead and fit view. And then also in view 1, make that active, we'll fit view. And then we'll zoom in to see the drainage and the existing. Exercise 5.3, create existing drainage from the Extract from Graphic tool. Before we begin from the drainage and utilities workflow and the layout tab and the layout group, we're going to be using the Extract from Graphics. We first want to see some of the features for the survey or the drainage. So we'll go to the element selection tool. If we select on the line between the drainage structures, we'll notice that we have some information that'll help us for modeling. So we can select on a drainage. In the drainage pipe, the description will tell us this is an 18-inch CMP, or concrete metal pipe. If we hover over another, we don't have a description, but that's how we can quickly and easily tell what type of drainage structure or existing drainage structure we're going to model. Is click on the line between the pipes. If we click on this drainage structure, that'll tell us by the field code that it's a mitered end section. But we're more focused on the line between the two structures. So we'll scroll down here, and if we select this is a 15-inch RCP. This is an 18-inch. So we have two 18 inches and a 15-inch. So we'll extract these graphics using the tool and set those as 18-inch. And then we'll come back and set the mitered end section. So once we've verified what drainage structures we're going to model, we can then go to the Layout tab and Layout group and extract from Graphics. We'll click the dialog or click on the tool. Setting up the tool, the method will be selection. We'll notice that after we select the elements, we may get the use 3D elements elevations and toggle that on by a checkbox. We'll do that later in the exercises. The vertical offset will remain 0 because we'll use the 3D element elevations. There's no design stage, but the feature definition, we'll click on that drop down. That'll take us to a conduit category. Then we'll go to the storm water, drainage pipes, circular pipes. You'll notice we have box pipes, elliptical, or pipe arch. So depending on your drainage structure, we have different categories. We're going to focus on the circular pipes. So we'll click on circular pipes, and then we want existing circular pipes. This will fill out the name prefix of EXP- and description is the pipe size. We'll change that to 18-inch. We'll have to come back and change this in the properties later. So once we have our feature definition selected and our description pipe size out, we can left click and data point to select the method in space in view 1. So we'll left click and data point. Now we've activated the tool for the selection method. It's going to ask us to locate the elements. So we'll select on the elements that we want to add to the selection set. So we'll do these two for the 18-inch. Once we're done, we'll reset by right-clicking. And you'll notice now that we have items selected, this Use 3D Element Elevations has become active. We can toggle it on by putting a check, or we can down arrow if we're using the tools. We want Use 3D Elevation set to yes. So we'll left click data point. The vertical offset is 0. We'll left click data point, and no, we don't want a trench because these are existing. So we'll left click data point. It's creating endpoints and creating the conduits and links. And then in the 3D view, you'll see that our pipe and nodes have been modeled. Also in the 2D view, we have nodes. We'll change these later. And a pipe. Close the tool. The pipes modeled. We'll come and select on the nodes. We'll notice that these are set to default. If we select on the property of the node, also we'll bring up the context menu. So if we select the node and then hover over, we'll have properties and utility properties. We want to select on the properties, the first icon of the node. We'll have feature name. Feature definition is set to none. We'll set that feature definition to one of the feature definitions in our library. We have the node category, so expand that out. Again, we're on the stormwater nodes, so click plus. In the drainage structures and existing drainage structures category, we're on existing outlets, so we'll click this folder. And then we'll find the existing mitered end sections for side drains and click on the plus. And then we'll navigate and pick the correct existing mitered end section. In this case, it's 18-inch reinforced concrete pipe, so RCP, an angle of 4, and the S stands for single. Select that. You'll notice once we select that, we now have our node changed from default to a drainage structure EX node. If we select on the outer limits of it, we need to change the manipulators for the rotation. So we need to rotate it to be true to the structure or the pipe that we just placed. So we'll rotate and then snap to the middle of the structure. And you'll notice I'll zoom out, in the 3D, it's setting the structure according to the pipe, so the orientation. We'll repeat that process for the node up above, and I'll zoom in and get that to show up. So we'll select the node that's on default. We'll bring up the properties of the node. using the context menu and then select Properties. We'll set the feature definition from the Properties dialog or Properties menu. We'll go to Nodes, Stormwater Nodes, Drainage Structures, Existing Drainage, and Existing Outlet, the existing mitered end section for side drains. And we want the existing MES S18 RCP 4S. Select that. We know that it changes from default to the mitered end section, and then we'll rotate using the manipulators and zoom out a little bit so we can see the center of the pipe, and we'll snap to the pipe. You'll notice that it changes direction and orientation, but our invert is not correct to the pipe, and the pipe size is not correct either. So the next steps in the exercise is we'll correct the pipes. But first, let's get the correct invert elevation on our drainage structure. So I'll zoom out because there's a couple of different parts to it. So there's a survey pin that will give us the elevations. We can either hover over it, and it has a survey elevation of 34.75. That tells us the flow of the pipe. If I select it and do Control I to bring up the properties, we'll also get the same dialog. If it doesn't come up, we can go back to the Home tab and pick the I. This should bring up the properties dialog over to the right. And it does. So we'll notice that the elevation is 34.75. So let's verify the other end. We'll zoom out to the other end. We can hover over the survey pin. So this elevation is 34.29. We can select that survey pin and verify that the elevation is 34.29. We can also click in the 3D view of the pipe. If we bring up the pipes, that will tell us our start invert and stop invert. So there's different ways to select it, but we want to set the structure to the correct invert size. So in my 3D model, I have this side active. I'll hover over this. So this is 34.29. So to change this, I will select in my 3D model or my plan view the structure element and then zoom in to this. You'll notice that that's going to adjust my invert by just clicking on it. And we'll notice that the size is different. We could type in after we select it the invert, so 34.29, so we can select that too, or we can just click on it and adjust. Clicking on the number will adjust our invert. Let's do that again for the base, this under section. So let me zoom in and zoom out of my 3D. Select the 3D element and then just click, that'll bring up the invert elevation. We can then come in and select on the invert and change that. So now our inverts match the pipe, but our pipe size does not match the mitered end sections. So let's click on the properties, or click on the pipe from the 3D view to bring up the properties for it. To find the properties, we'll open up the Feature tab of the Property menu. We'll notice that the feature definition is correct, but then the description is not. It's set to 12 inches. And by default, this is set from the tool. So we'll have to come back and change that from 12 inch to an 18 inch. And once that's set, you'll notice that the size of the pipe got bigger. So let's repeat those steps for the other pipe. That we have our pipe, we have our nodes. So the pipes are called links. The drainage structure are called nodes. So we'll select the node. We'll select and bring up the context menu and hover over it. So select the properties. We'll set the feature definition to the nodes category. Stormwater node, drainage structure node, existing drainage, existing outlet, the mitered end section for side drains, and the 18-inch RCP. We'll then select on the node, select the arrow from the manipulators to rotate so we can fix the rotation, and we'll snap to the center of the pipe. And we'll notice in the 3D view and our plan view that orientation is fixed. Our inverts are still off, but we'll fix that too. So let's go to our other node, and I'll zoom in and zoom out for the mitered end section. So our node, select it, then hover over it to bring up the context menu. Select on the properties, set the feature definition, stormwater node, drainage structure, existing drainage, existing outlet, existing mitered end section for side drains. We'll pick the existing mitered end section for 18, RCP 4S. We have that set, and now we need to fix the orientation. So when we change this, it brings in a 2D and a 3D. So sometimes if you select on one, it won't bring up your manipulators. Just go ahead and select the other one. That'll bring up your manipulators. And then we'll fix the rotation by selecting the arrows of the manipulators and snapping to the middle of the pipe. We'll fix the orientation. To fix the invert elevation, again, we can click on the survey pin from the line to verify we have 36.9 feet for one invert elevation. And if we scroll out and zoom into the bottom, we have 37.34 for the invert elevation. To set that invert elevation, we'll select our node. We can know we selected the node because we'll have the rotation. We can then select on this elevation oriented correctly to this drainage structure. If we click on this, we'll see that brings up the invert elevation. So we'll do the same thing on the north. So we don't have to set the invert, it'll set it for us. So, because it knows the invert off of the pipe. So we'll select the node. We'll change this manipulator for the elevation. We'll just click on it. That'll then set our invert elevation to the pipe. So that's changing the feature definition on the node and then setting the invert. We still have to fix the pipe. We'll do that from the 3D model or the 3D view. So we'll make that active. We'll select the pipe. That'll bring up the properties, and we'll go to the feature tab, and then in the description, we'll change 12-inch to our pipe size, which is 18-inch. So that is how we model our drainage structures. So we've modeled 2. You could repeat that process for your other drainage. To view in 3D, this would be exercise 5.4, viewing the drainage structure in the 3D view. So we can right-click and hold to bring up the view controls, and we'll search for 3 views. We want 3 views, plan XS, which is cross-section in 3D. We'll select that from the right-click menu. It'll ask us to open a dynamic cross-section view. Select OK to create a dynamic cross-section. So select OK. It'll then ask us to locate a corridor and alignment. So we have an alignment. So we'll left-click for our left offset, and then left-click and data point for our right offset, and then left-click and data point for the station. Our interval we can set to 25. And then select or open the view. We'll click in view 7. And we'll notice in our cross section, we see our existing modeling, or existing drainage modeled. We can move up or down or back and forth. We'll see our existing modeling. So that's how we view our existing drainage in a cross section. We can right click and locate the station via data point, select our plan view, Say we want to see our other view here. We'll see our model of our existing drainage. So we've created existing drainage and we've seen how it's viewed in the 3D and also how it's viewed in the cross-section view. Thank you for joining me today for the CAD Office series for FDOT Connect. This was Chapter 5 from the Roadway Design Existing Modeling Guide.